Human pollution greatly affects groundwater and is a growing concern because the contamination is widespread and difficult to control or get rid of. Groundwater is an important and often overlooked supply of drinking water. In just Texas alone, there are 9 major aquifers and 20 minor aquifers, and all have been exposed to a type of contamination. This information, provided by the Texas Environmental Almanac, is disturbing because of the government's failure to enact protocols and laws against such pollution of groundwater sources. Surface water is much more regulated. However, many people are extremely dependent on the groundwater reserves. Farmers use this water to irrigate crops and water their livestock, but if it is contaminated, the water threatens their entire livelihood. The health hazards are not limited to the crops and animals. Humans drink and bathe in this contaminated water and can become sick. A health blog in France 24 emphasizes the growing concern that nitrates and pesticides found in the water promote the development of cancerous cells. Another way in which humans become exposed to this type of contamination is through eating animals or plants that have used the bad water to survive. Although the Texas Environmental Almanac plainly says that groundwater contamination can be a natural occurrence through saline water from deeper aquifers seeping into aquifers that provide water for humans, and also groundwater may have naturally high background levels of nitrates, metals, iron, sulfate, or chloride, all of which can give water an odd odor, color, or taste. The most alarming contamination is still due to human pollutants. An ongoing problem in Hinckley, California accentuates the danger of allowing contaminants into groundwater. A Los Angeles Times article covers the story of ineffectual government actions to contain chromium and the protest of residents in the area. The chromium-tainted water causes cancer and other serious illnesses, and the Pacific Gas and Electric Company did nothing to stop the spread of this contaminant. Environment Canada emphasizes that once groundwater is contaminated, it will be unstable for decades, and the contamination does not end there. It spreads to lakes and springs and then gets into the atmosphere, where the water cycle will dump the pollution elsewhere. The manner in which the groundwater becomes contaminated includes industrial plant waste, sewage leakage, agricultural runoff, mining, and underground pipes and tanks leaking. Industrial plants will emit waste that is not regulated, and before any laws were put in place, hazardous waste would be buried in storage containers that would eventually erode and leak. These chemicals and toxic waste will then seep into the ground until all of it comes in contact with an aquifer or other groundwater source. Also, when nuclear power plants leak or a spill occurs, radiation has the potential to seep into the underground water supply. CNN covers the nuclear power plant spill in Tokyo, Japan, and the evacuation of people from the area, as well as the fishing restrictions of a 12-mile radius around the plant. This emphasizes the severity of problems such as this one. Landfills also create a problem because the sewage seeps into the ground to mix with the groundwater. Landfills are everywhere, and the older ones were not built with the environment in mind. The trash will continue to break down and release chemicals and other bad things into the environment. Farmers create some of their own issues when they put too much fertilizer on the crops growing. Some fertilizers are worse for the environment, and when it rains, the water will mix with the chemicals and nutrients found in the fertilizers to seep into the soil. A Texas A&M sponsored environmental site states that extensive use of herbicides has resulted in widespread detection of herbicides such as atrazine, metochlor, alkachlor, and cyanazine. Mining and de-icing roads share a similar effect on groundwater. Both increase the salinity of the water and make it undrinkable. Mining uses superheated water injected into the environment to mine uranium and sulfur, while salt is placed on icy roads and drains off into the environment. The British Broadcasting Corporation describes the effect of uranium on groundwater. The mining of uranium since the Cold War has led to many still continuing problems because containing this uranium is difficult. The BBC does, however, show that bacteria nanowires may prove to be helpful in cleaning up the groundwater supplies. The contamination is not only present in the United States and Canada. China has also been dealing with similar problems and gives varying reports on the success of containing the pollution. In an article of China Daily, the author states that the Chinese government has placed controls on pollution of groundwater for the first time. The national plan provides money for 6 categories of regulation, survey, prevention, remediation, control, and monitoring the capacity for water reserves to handle pollution. Another article in China Daily, however, contradicts this good news. The author shatters the facade of regulation and states that more than half of the groundwater-dependent major cities fail to meet the standards of drinking water safety. The Environment 360, a site created by Yale University, shows the extent of the problems in groundwater throughout Southeast Asia. It states that not only does arsenic pollute the sources of drinking water, but also is widespread and not a pollutant that is easily contained. This specific pollution has gotten out of control in the world, but the United States Environmental Protection Agency presents several ideas that could potentially control the problem of groundwater contamination. 2 main ways of ridding pollution from the water seems the most effective. Pumping out the contaminated water from the aquifers and cycling it back after removing the pollutants is an option, as is putting chemicals and influencing naturally occurring processes to rid the pollutants. We must remember that the solution to pollution is dilution. So in order to make the water drinkable when it is contaminated, much more water is needed to be pumped in the underground reserves, and it develops into a less available option. Thus, groundwater contamination remains a dire problem throughout the world and is important to stop altogether.